Assalamualaikum warahmatullahi wabarakatuh. We group 1 and here we will present about synthesis and characterization of Schiff compound from vanillin and p-Anisidin using Greenstone method.
My name is p-Anisidin and I will explain briefly the background of the research. The increasing development of the technology in this modern era has an impact on all sectors. The medical field is one of them that has experienced development, especially in the medicine developed by the world of pharmacology. Milling method. In this Praktikum experiment, it was carried out in synthesizing a Schiff-based compound from vanillin and p-Anisidin using the milling method without a solvent and catalyst. The advantage of the grinding method are that it doesn't use solvent and catalyst, including reducing waste product that can be harmful to human and the environment, saving energy, being simple, cheap, and faster. Aim of the research: 1. Knowing the result of the characteristic of the synthesis product of Schiff and vanillin and p-Anisidin based compound using the grinding method. 2. Knowing the yield produced in the synthetic Schiff based compound. 3. Knowing the identification result of Schiff based compound using the UV spectrophotometer, FTIR, ENMR, and ECMS.
Methodology. Number 1. Tools. A set of glassware, suction valves, mortar and pestle, analytical balance, desiccator, porcelain cup, melting point asparagus, thermometer, filter paper, capillary tube, UV spectrophotometer, STIR, HNMR, and GCMS. Number 2. Material. Vanillin, p-Anisidin, chloroform, NaOH, TMS, CDCl, ethanol, KBr, and aqueous. Step of the research. Number 1. Compound synthesis. Number 2. Monitoring by KLT. Number 3. Melting point test. Number 4. Physical and chemical test. Number 5. Identification using a UV spectrophotometer. Number 6. Identification using a FTIR spectrophotometer. Number 7. Identification using a HNMR spectrophotometer. Number 8. Identification using a gas chromatography mass spectrometry.
Okay, I'm Ophelia. Now I will explain about the synthesis of Schiff base from vanillin and p-Anisidin by grinding method. The Schiff base synthesis method used is the grinding method without using a solvent and also a catalyst. The grinding time is carried out for 20 minutes until the reaction arrives completely. The reaction for the formation of the Schiff base compound for vanillin and p-Anisidin is an addition-elimination reaction. The reaction for the formation of the Schiff base compound for vanillin and p-Anisidin is shown the following picture. Okay, next, the reaction mechanism. Step 1. The reaction of primary amine addition. And then step 2. Elimination reaction will begin with the protonation of the OH group. In the mechanism described, step 1 is the step where the addition reaction occurs by breaking the double bond on the carbonyl group C double bond O to form a single CO bond. Whereas step 2 is a step where the elimination reaction occurs with the formation of the double bond that occur in the C and R bond to form C double bond and R. The synthesis product obtained in greenish gray. The physical characterization is carried. Okay, and then this method after being processed, it is put in a desiccator and weighed. The yield was 94.86%, where this result is quite good and is close to the percent which corresponds to the theoretical 100%.
Characterization of using UV spectrophotometer. Analysis using a UV spectrophotometer was used to determine the maximum wavelength of a product compound. It is known that the product compound has been formed by looking at the maximum wavelength of the product compound, which is different from the maximum wavelength of the reactant, namely vanillin at 179 nanometers and p-Anisidin 30 to 100 nanometers. Based on the spectra of the absorbed energy, product compound experience electron excitation from the basic energy level to a high energy level, with a maximum wavelength of to 183 nanometers and undergoing a transition of P to P stars.
My name is Andorisia. At this time, I will explain about synthesis product monitoring using thin layer chromatography or TLC. Result: monitoring with TLC was carried out to determine the possibility of a target compound having been formed based on the formation of sign with an area value that was different from the area value of the reactants, so that we could expect a target compound. Lanjut enrollment 2007. The mobile base used form the methanol or 9-1 with a stationary base, namely silica, on the TLC plate G-F 2054. And then the result of TLC with 254 nanometer UV lamp irradiation obtained yellow stains with the area value on spot 1 of 0.04. This is different from the area value of vanillin and p-Anisidin, where stain 2 is 0.77 and the same color as vanillin, so it is suspected that there is vanillin residual reaction on stain 2. Based on the result obtained, it can be assumed that the target compound has been formed with the remaining vanillin in the resulting synthesis product.
Okay, my name is Safira Arila. I will explain about synthesis product characterization by solubility test. Solubility test function to determine the formation of 2-methoxy-4-methoxy-polyamino-metal The compound 2-methoxy-4-methoxy-polyamino-metal acts as an acid and NaOH acts as a base. In this reactants produces a salt product which will later be dissolved in water. Obtain a solution that changes color to yellow and is in the form of a little precipitate. This indicates that the synthesis product is slightly solved in water. Add with this synthesis, NaOH dissolves completely and is yellow in color. Okay, it can be concluded that the synthesis is slightly solved in water. It will dissolve completely when added with NaOH.
Test of synthesis product melting point. Melting point testing using the melting point apparatus obtain the melting point in the synthesis of base compound of 128 to 131 degrees Celsius at the year 2017 by having a form in the form of a light brown solid, which is different from the vanilla reactant, which is a white solid, and p-Anisidin is black.
Okay, I am Izatul Ilmiah. I will explain about characterization of using FTIR. FTIR is a spectrophotometer based on interaction a molecule using electromagnetic radiation. This tool is used to find out and analyze the type of functional group contained in a compound. This tool can also be used to determine molecular structure information of an organic compound. The result of the FTIR spectra of the synthesis product, there is a sharp and strong absorption from the functional group CN, which is the typical absorption of the target compound at a wave number of 1519 cm. Based on the obtained FTIR spectra analysis, it is suspicion that the target compound has formed in the synthesis product. Next is the result of the FTIR spectra.
The result of characterization using gas chromatography mass spectroscopy in this study were obtained at peak 1 at the retention time of 2.174 minutes with percent area of 2.34 and peak 2 at a retention time of 23.624 minutes with percent area of 97.66. A peak mass spectrum 1 has molecular ion with charge ratio 118, value equal to the molecular weight of chloroform, so peak 1 is strong to be chloroform solvent. While at peak 2, analyze with a mass spectrometer so that the mass spectra has an charge ratio value of 2057 molecular ion value correspond to the molecular weight of the target compound. It is strongly suspect that peak 2 is a 2-methoxy 4-methoxy vanillino methylphenol compound.
And the last characterization is characterization using HNMR. Characterization using HNMR aims to determine the type of hydrogen atom in the synthesis for the molecule. The H-NMR spectrum can provide information related to the chemical shape of the protons, the number of the protons, and the shape of the signal. This is a H-NMR spectrum of synthesis from synthesis Schiff base, and then this the result to the functional group and the wave number of the target compound. Based on the data, it can be concluded that the synthesis product is a basic compound Schiff 2-methoxy-4,4-methoxy-phenylamino methylphenol with an aromatic nucleus which has a methoxy group substitution.
Conclusion: the characterization result of the synthesis product of the Schiff-based compound with the vanilla and p-Anisidin reactant using the grinding method. Namely, the sample is light brown, slightly soluble in water, and the melting point is 128 to 131 degrees Celsius. The yield product in the Schiff-based synthesis compound was 94.86%. In the TLC result, there is yellow spot 1, which is thought to be the target compound with an RF value of 0.84. Solubility with water gives a yellowish solution by forming a precipitate. When dried with sodium hydroxide, the precipitate completely dissolves yellow. Characterization of the Schiff-based compound using FTIR showed that there was a typical absorption of the target compound, namely C double bond N in the 1590 cm to the power of -1 area, while the characterization using GCMS contain molecular ions at ampere Z 257, which correspondent to the molecular weight of the target compound, and so peak result at retention time of 23,624 minutes with an area of 97.66%, while the characterization using UV obtained the maximum wavelength of 336 nanometer and 238 nanometer, and the characterization with H-NMR obtained a unique signal of the proton immunizing at a chemical shift of 8,42 ppm 1H.
Okay, it was a presentation for our group. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.